Okay, what's up, virtual learning people? Today I'm going to do a lesson on how to do fraction times a whole number. For example, 3/5 times 10 or 10 times 3/5. This is a 5th grade standard for Virginia. I teach in Virginia. And something important to remember is that whenever you're doing a fraction times a whole number in 5th grade in Virginia, the denominator of your fraction must be a factor of the whole number. So that way you can see 5 fits into 10. It's a factor. It's going to stop us from having fraction quotients. It's always going to be a whole number quotient. And in Virginia, students are expected to model this, be able to see it, and we do not expect them to just use any algorithm. We really want them to make sense of the problem. So, with that being said, we always want to start with a story or a problem context, because if we do not give, we only give students this, the numbers, but not this, then they'll never actually know when this type of math actually applies in their real life. So this is a context that would match that problem, 3/5 times 10. It says, Sam is practicing for a marathon race. His goal is to run 10 miles without stopping. Today he completed 3/5 of the 10 miles before stopping. How many miles did he run before stopping? So I'm going to show you a few different ways that students might think about this problem. They are not the only ways, but just to give you some examples of how it looks like when we're teaching this kind of stuff in school. All right, so first thing, I know that he completed 3/5 of the 10 miles. So that tells me that I'm going to be doing 3/5 times 10, because this means 3/5 of 10 miles. You can also think about this as 10 groups of 3/5. The reason why you can think about this both ways is because of that commutative property. We know that whenever we're multiplying something, we can switch the factors around and our product would still be the same. And here's my son. Say hi.
Hi.
All right, you can sit to the side, but please don't interrupt my video, okay, babe? Okay. All right, so let's start thinking about this. I will show you a longer way that you can model this problem first, and then I will show you a shorter, more efficient way. So let's just say that students read this story and they were thinking about 10 times 3/5 or 10 groups of 3/5. How would that look? So then let's think about 10 groups of 3/5. Here's one set, and I'm going to show 3/5. That means I need to divide this into fifths, or 5 equal parts, and then I'm going to show 3/5 by labeling 3 of the fifths. So this is one group of 3/5, but in order for it to match this problem, I need 10 of these. So I'm just going to keep going. Alright, so if teachers were modeling something like this in the class with students, they might use hands-on manipulatives like fraction circles or fraction tiles, and they would use 10 groups of 3/5, and then they would be putting those fifths together to make wholes, and we all know 5/5 makes a whole, but I also know that parents at home don't always have fifths and fraction bars laying around. So this is another way that you can show it visually without the hands-on manipulatives, and this is what we would have students transition to after they had experience working with the concrete material. So let's take a look at what we have here. Now can you see that we have 10 groups of 3/5? I have 3/5 10 times, okay? So let's see how many fifths that would be. 3/5 plus 3/5, well, that would be 6/5, right? And then if this is 6/5, Kai, if this is 6/5, then this is 6/5, and 6/5 plus 6/5 would be 12/5, right? So if there's 12/5 here, and then I doubled that, then that would be 24/5 plus 3 more, 4, 5, 6, 7, 27/5, 28, 29, 30. There's 30/5 here, right? Okay, so 30/5. That's the same as 30 divided by 5, and 30 divided by 5 would be 6. So for this problem, Sam is practicing for a marathon race, and it's asking how many miles did he run before stopping. This 6 would represent 6 miles. Now, if you did not want to draw out all of those area models to show 10 3/5, because that's a lot of drawing, you could just do 10 groups of 3/5 like this. 1, 2. But if you do all your unit fractions like this, all these 1/5, and you do 3 1/5 10 times, students understand where the 10 times 3/5 comes from. And what you can also show them on this fraction chain is where the 6 comes from. Because I know that 5/5 is the same as 1 whole. So if I box these 5/5 together, I know that's the same as 1 whole. And then this is another 5/5, so that's the same as another 1 whole. And this would be another 1 whole. And let's see, this is another 1 whole. This is another 1 whole. And this is the last 1 whole, which would be 1, 2, 3, 4, 5, 6 holes. Now, if they did not want to do all of the single 1/5, they could also think about the 10 3/5 like this. 1, 2, 3, 4. I know that this seems like a lot of writing it out, but this is going to help students connect what they know about multiplication of whole numbers to fraction multiplication. And once they make that connection, a lot of this harder fraction math will make more sense to them. So then you can add up those fifths, and this really matches this top model up here. So 3/5 plus 3/5, that's 6/5. Another 6/5 is 12/5. If I double that, that would get me up to 24/5, 25, 26, 27, 28, 29, 30/5. And again, we know that 30/5 was 6 because we already did that math up there. So those are 3 different ways that you could show it by doing 10 groups of 3/5. And now I'm going to show you how we can use the commutative property to think about that even more efficiently. I'll set this to the side. So the way that we just modeled it was kind of thinking about 10 groups of 3/5. But even if I had a problem that in my brain looked like 10 groups of 3/5, I could think about it as 3/5 of 10. And for me, this is easier to model. So 3/5 of 10 means that I have a whole of 10. And I need to now divide that whole of 10 into fifths, or 5 equal parts. Now you can see these 5 equal parts, so each of those equal parts represents 1/5 of the whole set of 10. Now since the set is 10, I can think about what number multiplied by 5 would get me up to 10, or 10 divided into 5 groups, 1, 2, 3, 4, 5, would give me how many each group, or I could just deal out 10. Got 10 now, okay? Now if I want 3/5 of 10, then I need to really focus on 3 of these fifths. So 3/5 of 10, what do you see in the boxes? 1, 2, 3, 4, 5, 6. There's my 6 miles that he completed when I thought about it as 3/5 of 10. As you can see, this is a lot less to draw. That doesn't mean that there's anything wrong with a student who's modeling it in any of these ways, but as students continue to practice and develop more efficient strategies, using the commutative property is something that can help them be more efficient and not feel like they have to show as much thinking. I'm going to give you guys another example. All right. Let's try a different story. We won't do fifths this time. Let's take a look at this one.
Mama?
Yes?
I'm sorry for spilling this. It's just there and that was the circle and they can stick together.
Okay, well you can play with that as long as you're not interrupting my video, okay? All right, so let's take a look at this context. So this context is saying that Sarah is making 8 cakes for a big party. Each cake will use 3/4 cup of sugar. How many cups of sugar will she need for 8 cakes? Again, this context is going to provide some relevance for the students to solve the problem. They'll be able to think about, oh, now I can see when I would use math like this in my real life. If I was thinking about cooking or catering, I would definitely need to use fractions for something like this. So let's think about what this problem is asking me. It's telling me that I'm going to have to make 8 cakes and that each cake is going to use 3/4 of cups of sugar. So that means that I would have 8 groups of 3/4, or I could use that commutative property and think about it as 3/4 of 8. So again, this is 8 groups of 3/4, and this would be 3/4 of 8. So let's start by modeling the 8 groups of 3/4, okay? So let me make one group, one set of 3/4. So that would be one whole split into 4 equal parts. I'm just going to label 3 of the fourths. So this is one set of 3/4, and I'm going to repeat that until I have 8 sets of 3/4. So I know I said this before. If you were in a classroom teaching this, we would always start with concrete manipulatives like fraction bars or fraction circles, and we would have students take all these 1/4 pieces and show the groups of 3/4 and then multiply that 8 times and then make all the holes that they could make, and then transition to what I'm doing right now, which is drawing. But since I'm trying to make virtual videos for parents and students who probably do not have manipulatives at home, I'm trying to do the best that I can do with representations that might make sense. Okay, so now you can see I have 8 groups of 3/4 here. So let's think about how many fourths that would be. If there's 3/4 here and 3/4 here, that's going to be 6/4, right? Plus another 6/4 here, that's 12/4. And then if that's 12/4 and I double that, then 12/4 plus 12/4 would be 24/4. When I have 24/4, I can think about that as 24 divided by 4. And I'm thinking, what number can fit into 24 4 times? And I believe that it's 6, because if I did 24 divided by 2, that's 12. And I divided that by 2 again, that would be 6. So I'm thinking it's going to be 6, and since the problem is asking me for how many cups of sugar will she need, I know it's going to be 6 cups of sugar. All right, now let me see. If I did not want to draw out all those area models, I still wanted to show 8 groups of 3/4, I could do it with my unit fractions. Okay, and I know that 4/4 makes a whole, right? So now if I start grouping up 4 of those fourths together, now that's good. Rectangle is going to represent one whole. So there's 2 holes, 3 holes, 4 holes, 5 holes, 6 holes. You can also see that I got 6 cups of sugar this way. Now, if I didn't want to stretch out those 3/4 into 3 1/4, and I just wanted to think about it.
You can use this.
Thanks, baby. And I just wanted to think about it as 8 3/4. I can also think about it like that. I'll do 1, 2. This is why it's so hard to make videos with kids, y'all. I'm gonna do let's see if I have 8 yet. 1, 2, 3, 4, 5, 6, 7. I'm gonna do one more 3/4. And when I add up all these 3/4, it's gonna be 6/4. 6/4 plus 6/4 is 12/4. 12/4 plus 12/4 is going to be 24/4. And you know that's still gonna give me 6. So all these ways are ways that students might model this problem of 8 groups of 3/4. All right, so that looks like a lot of work, but remember how we were talking about students working toward using the most efficient strategies? They don't always just jump there. We want to make sure that they are understanding the math. But if I wanted to do this with a little bit less work, if I wanted to use that commutative property, and instead of thinking of 8 groups of 3/4, I can think 3/4 of 8, because 8 groups of 3/4 really matches this problem exactly, because I do have 8 sets of 3/4. But I might realize that if I thought of it as 3/4 of 8, and I flip those factors, I would get the same product. It would be easier for me to model that. So let's take a bar model, and let's say that this whole bar is going to represent 8, those 8 cakes that I'm making. And since I want to know 3/4 of 8, I need to split 8 into fourths. So each of these would be 1/4 of 8, and then 4/4 of course makes the whole. Okay, so if I have 8 and I divide it into 4 parts, 8 divided by 4 would give me 2 in each group, or I could think 2 4 times gets me up to 8. Or remember, it's also okay if you wanted to have 8 and then just divide up 8, and you can see it's still going to be 2 in each group. I'm going to leave this one with the numbers since I've already showed you one with the circles. So now if I wanted to know what is 3/4 of 8, I know 1/4 of 8 is 2. 2/4 of 8 would be 4. 3/4 of 8 would be 2 plus 2 plus 2. So 3/4 of 8 equals 6, because that's 2 plus 2 plus 2. So then I know 8 times 3/4 is also 6. So that's much less work for your hand, but you do have to have understanding of how that commutative property works to be able to think about it that way. So those are 2 examples of fraction times a whole number that match Virginia's 5th grade standards. So happy practicing. Let me know if you have any questions. Feel free to comment below.